Now we're going to take a look at arcs and sector areas of circles, and those will be used in geometric probabilities. So what is an arc? Usually, an arc is just a portion of the edge of a circle between two points, two endpoints. So you can see here's point A and point B, and that is arc AB. Sometimes the notation will be something like this. It'll be, for this segment right here, you'll write A and B and then put a little arc on top of it. So it's just kind of like a segment, but it's not because it's curved. So it's a piece of a, I hate to say a line because the geometry teacher in me says no. All right, well, the length of the arc is proportional to the number of degrees in the central angle here. So since the whole thing is 360, all I have to do is figure out what fraction this angle is of the whole circle. So you end up with x over 360 times the circumference. So you have this fraction right here. Now we're going to take a look at an example. Sarah's designing a spinner for a choir fundraiser, and she wants to put pink tape along the edge for the doll, yellow tape for the balloon, and blue tape for the car. The arc for the doll is 80, and for the toy car is 120. How much yellow tape will she need if the radius of the spinner is 10 inches? So the 10 inches would apply to this length right here. Well, first of all, I know all three of these must add up to 360. So I call this angle x, or yes, x plus 80 plus 120 equals 360. X plus 200 equals 360. Solve for x, and I get 160 degrees for the balloon. Well, to find the amount of yellow here, I just put in that angle, 160, over 360, times the formula for the circumference, 2 pi r. That, I can simplify the 160 and the 360, divide out the tens. And the radius is 10. Here we go. And then, honestly, I just got my calculator and substituted in. And to the tenths, it's about 27.9 inches. That is the arc length. Now, sector area is very similar. We are looking at the region bounded by two radii, and this is called the intercepted arc here. It looks just like the formula that we had before. We still have the same fraction, x over 360. The only difference is now we're using area, so we're using the area formula for a circle, pi r squared. So in this example, I'm going to find the area of the two white sectors in this circle. I'm going to start by just focusing on one sector. So area 1 is going to be 40 degrees over 360 times pi r squared. Well, I can see that the radius from over here is 15 inches. So that means I simplified this already. So it's 1/9. And pi and 15 squared. So it's 225 pi over 9. You're probably thinking, oh, this is really messy. But actually, if I leave it in fraction in exact form, it works out neater. So I'll show you why. So the total area is going to be two of these arcs. They're the same size. That's the center of the circle. This is congruent to that. So if I multiply it by 2, I get 450 pi over 9. Well, 450 is divisible by 9. My total area is just 50 pi. So some questions to think about for this page of notes. What is the arc length and how do you find it? What is sector area? So what's the difference between arc length and sector area? And how is the sector area formula similar to the arc length formula?